Hi my dear student, today we will discuss about partial fraction. Introduction about partial fractions. See, we have so many types, we will discuss one by one. 1. We have 1 divided by x plus a into x minus b. See, the highest power of x is 1, it is linear. The highest power of x is 2, that is quadratic. Highest power of 3 is cubic. So, in previous, power 1 says linear, power 2 says quadratic, etc. Power 0, it is constant. For example, if I have a fraction 1 divided by x plus a into x minus b. Here in each bracket, it is linear. What is the previous one which is constant? Here I am going to consider the constants are capital letter A, B, C, etc. So this will be splitted as a by x plus a plus some constant capital B by x minus b. Suppose you have 1 by ax plus b into x minus c. Got it? This is linear, this is also linear. So I will write some constant capital A divided by ax plus b plus some constant capital B divided by x minus c. Suppose 1 by x plus a whole square into x minus b. Here x plus a repeated twice. So we wanted to start a divided by x plus a plus b divided by x plus a whole square plus some constant c divided by x minus b. Here when you see power 2, so I will write some constant by x plus a power 1. Again some constant by same x plus a power 2. And for x minus b I will write some constant capital C divided by x minus b. Suppose you have 1 by x minus a whole cube. Only one factor x minus a which repeated 3 times. We have 1 by x minus a whole cube. Here a by x minus a power 1 plus b by x minus a power 2 plus c by x minus a power 3. So when the power repeated more than once, you wanted to write power 1, power 2, power 3. Okay. Now you have a quadratic one, some x square plus 1. I will write some ax square plus 1 and x minus b or x plus b. No problem. I will consider 1 divided by ax square plus 1 into x plus b. Here, suppose if you can able to factorize this ax square plus 1, this is a quadratic one. If you can able to factorize, it will be like this or it will be like this. Suppose you cannot able to factorize. Okay, in this case, you cannot able to factorize. In this case, you want to write this is degree 2. So, what is the general form of degree 1? Here linear, degree 1, the previous stage is constant. Here degree 2, the previous stage is linear. What is linear format? Some ax plus b divided by ax square plus 1 plus some constant c divided by x plus b. See here, I have 1 divided by ax square plus 1 into x plus b. Suppose if you can able to factorize this quadratic one, it will be like this or like this. Then you can follow this one. Suppose you cannot able to factorize this quadratic one, you wanted to write the previous general form of the quadratic one is linear. That is some x, some constant, ax plus b. Some a times x plus b. This is the general form of the linear. Then write this quadratic one plus for this x plus b, you will write plus some constant c divided by x plus b. Okay, suppose you have a cubic polynomial which you cannot able to factorize. In such a case, you wanted to write what is the cubic previous case, which is quadratic. You wanted to write the general quadratic equation divided by the cubic one. For example, which is not in your syllabus, anyway I will write. Suppose I have ax cube plus cx plus d, some cubic, degree x is 3. You cannot able to factorize. Then what do you want to write? This is degree 3. What is the previous one? Quadratic. What is the general form of the quadratic one? Some constant x square, some constant x, some constant c divided by ax cube plus cx plus d. Got it? Suppose you have cubic polynomial here, you cannot able to factorize. Then what is the degree here? 3. So 3 minus 1, 2. So you want to write the general second degree, that is ax square plus bx plus c. and write the cubic polynomial here. Here cubic means the previous one quadratic will come. Here quadratic means the previous one linear general form will come. Here linear means the previous one is constant. That's why I use capital A here. Okay. So can you understand how we are writing the fractions in this way? This is not in your syllabi, but you must know the reason why we are writing A here, why we are writing ax plus b here. If the power repeated, why we are writing like this? Is it clear? In first 6 cases, I use the numerator as 1. Suppose you have some ax plus b divided by x plus a into x minus a. No problem about this one. Some constant a divided by x plus a plus some constant b divided by x minus a, etc. Now, in first 7 cases, the degree of the numerator is always less than the degree of the denominator. In first 7 cases, whose degree is always more than the numerator. We may discuss with constant or something, but anyway, the degree of the numerator is always less than the degree of the denominator. Suppose degree of the numerator and denominator are equal. You wanted to use a long division method to proceed the problem. Is it clear? Suppose degree of the numerator and the denominator are equal. You wanted to use a long division method. In this case, I am going to consider an example problem which is very comfortable to explain. Is it clear? See, in this case, we have x square plus x plus 1 divided by x square minus 5x plus 6. Here the degree is 2, here also the degree is 2. If it is possible to factorize, you can factorize. X square plus x plus 1, I cannot able to factorize. For x square minus 5x plus c, I can able to factorize, which gives x minus 3 into x minus 2. But anyway, when you factorize the denominator, you may get 2 linear. But you cannot able to factorize the numerator. Suppose if it is common factor, you can cancel directly. So in this case, which is not possible. See the degree 2, here also degree 2. I am going to use a long division method to split in the very first step. See, I'll use a long division method. I have x square plus x plus 1, which is in the numerator. It will go inside. And the denominator x square minus 5x plus 6. Okay, I am going to use a long division method. First term divided by first term gives 1. So x square minus 5x plus 6. I think remember you studied in 9th standard. Change the sign. It get cancelled. 5 plus 1, 6x. 1 minus 6 minus 5. So in this case, I can write 1 plus, write this one, mixed fraction format, by x square minus 5x plus 6. Can you remember a mixed fraction? The quotient plus the remainder and the divisor. This is what we will write. For example, I have 25 divided by 3. So 25 divided by 3, 8 times 24, it gives 1. See how we are going to write 8 plus 1 by 3. Okay, for mixed fraction we may write like this, 8 1 by 3. 8 3s are 24. 24 plus 1, 25 by 3. So you can write this fraction as mixed format like this. The real is 8 plus 1 by 3. When you take LCM, 8 3s are 24 plus 1, 25. So quotient plus remainder divided by divisor. Quotient 1 plus remainder divided by the divisor. So when you split like this, if the degree of the numerator and degree of the denominator are same, you want to use a long division method, then you will get something 1 plus like this. In this case, strictly degree of the numerator is always less than the denominator, because we divide, no, something you will get here. In this case, same degree, so I will get surely constant, some constant plus linear divided by quadratic in this case. So when you use long division method, this fraction can be splitted like 1 plus 6x minus 5 by x square minus 5x plus 6. Now consider this 6x minus 5 by x square minus 5x plus 6 separately. Proceed the problem like this and finally add with 1. Got it? For this one only, you want to use a partial fraction, something like this. You want to split, find the value of a and b, and then substitute here. You will get 1 plus something here. See, sir, everything is okay. We know how to split a by this, b by this, something like this. How can you find the value of a and b? It's very simple. You wanted to equate the factor which you have in the denominator say 0, you will get x value. When you substitute after taking LCM, it will be proceed. You must know how to split first of all. While doing the problem, you may can understand how can you calculate the value of A and B. It's very simple. Simply equate the factor to 0. Substitute here, you will get the value of A and B. Sometimes the factor may be repeated like x plus a whole cube. We discussed one case now. Same x plus a only will be repeated in all the three denominator. In such a cases, you wanted to equate the highest power of x coefficient on both side, or something you want to substitute 0 or 1, some constant. You make it some linear. You wanted to solve, etc. That we will discuss while solving the problem. Basically, you should know how to split the fraction. How to split the fraction as partial. Partial means we are splitting so many parts, no. That is what partial fraction. So in this case, if the degree of the numerator and degree of the denominator are equal, you want to use a long division method. Write quotient plus remainder divided by the divisor. Suppose degree of the numerator is more than the denominator. Degree of the numerator is more than the denominator. Very first, degree of the numerator less than the degree of the denominator. Then degree of the numerator which is equal to degree of the denominator. Now we will discuss degree of the numerator is more than degree of the denominator. Here also I will consider one example to explain in a better way. Okay. See, in this case we have x cube plus 2x plus 1 divided by x square plus 5x plus 6. Here degree of the numerator is greater than the degree of the denominator. Okay, here I want to use a long division method. Write the numerator which is x cube. No x square term. For standard I will write some 0x square and plus 2x plus 1. Numerator x cube. X square term is missing. So 0 times x square and 2x plus 1. Write the denominator here. X square plus 5x plus 6. Here also suppose you can able to factorize this one and this one. If common factor appear, you can cancel. Otherwise you wanted to use a long division method. In each case you wanted to factorize if it is possible. If common factor comes, you can cancel. Otherwise you wanted to proceed like this. So here degree of the numerator is greater than the denominator. I will use a long division method. First term divided by first term gives x. Multiply x into x square x cube, x into x 5x square, x into 6 6x. So change the sign. Cancel. Minus 5x square. We want to consider this sign. 2 minus 6 minus 4x, and this plus 1 you wanted to drop. First term divided by first term gives x. So x into x square x cube, x into 5x 5x square, x into 6 6x. I will change the sign. Cancel. 0. This is minus 5x square. 2 minus 6 minus 4x plus 1 you will drop in the next case. Divide the first term by first term. Divide this first term by this first term. You will get minus 5. Okay. Multiply minus 5 x square. Minus into plus. Minus 5 5s are 25. X. Minus 5 into plus 5x. That is minus 25x. Minus 5 into 6. Minus 30. Change the sign. It will be plus. It will be plus. It will be plus. Cancel. 25 minus 4, 21. X. 30 plus 1, 31. So in this case, your degree is 2, your degree is 1. So I will stop. Quotient x minus 5 plus remainder 21x plus 31 divided by x square plus 5x plus 6. Okay. Sir, in previous case you stopped with one time, but you repeated here because when you are getting the remainder, always degree of the remainder is less than the degree of the divisor. Okay. It's quite common. So in this case, very first I use a long division method. I am getting x, and then again when I am going to divide, I am getting minus 5. In this case, I am getting the quotient as x minus 5 plus remainder 21x plus 31 divided by the divisor. You wanted to apply partial fraction only for this one, that is 21x plus 31 divided by x square plus 5x plus 6. Okay, split like this. Finally add with x minus 5. So very first 7 cases, degree of the numerator less than the degree of the denominator. We may discuss how to split, etc. Suppose degree of the numerator and denominator are equal, or degree of the numerator is greater than the degree of the denominator, you want to use a long division method. Where we want to stop the long division method, suppose we are getting the remainder whose degree is less than the divisor, then stop. Write the quotient plus remainder divided by divisor. Then apply only partial fraction for this one. Only this part, not for the quotient part. Is it clear? This is the basic structure. Here we discussed about how to split that one. Hereafter only we may going to discuss how to find out the value of A and B. That while solving the problem you may can understand. At present you must know how to split the partial fraction. In partial fraction when you discuss, basically we are going to split the fraction as partially like this. Where we are going to use mainly in case of differential calculus. In future you may discuss differential calculus. It is one of the very important topic in engineering field. That we must know how to split the fraction like this. Then only you can able to differentiate. Mainly you should know how to integrate also. In case of integrating a fraction something like this, you may cannot able to do directly. You want to apply partial fraction. Don't think a partial fraction just we are splitting a fraction something like this. Why we are splitting? In case of differential calculus or integral calculus, if we are going to consider something like this, you cannot able to calculate. You wanted to split like this, then you can integrate or differentiate, whichever is. But this is fundamental one. For fractions you may know how to split like this. Okay, but in future it is very important topic in case of calculus like differential or integral. Even in so many topics also we may use. Sometimes you cannot able to proceed with the fractional something like this as it is. You wanted to use partial fraction. Okay, got it?